Okay, today we're doing 2.1 functions part 2. So we'll just start with an example. We're going to evaluate this function given, which is 2x squared plus 3x minus 1. We're going to evaluate it at f of a and f of negative a and f of a plus h. So, and then d is down at the bottom, that big fraction that we're also going to evaluate it at that spot. So basically this is just like plugging in a number in for x. Instead of plugging in a number, we're going to plug in a. So we're going to write f of a equals 2a squared plus 3a minus 1. And then I'm going to write that without the parentheses. And then that's as simplified as it gets. So that's just our answer. Okay, pretty straightforward. Same with negative a. So let's go ahead and plug in negative a for x. I'm going to use parentheses here because I don't want to mess up my negatives. And then so f at negative a equals 2. Negative a times negative a is going to become positive a squared. And then minus 3a and minus 1. And then that's as simplified as that gets, so that's done. And then f of a plus h, so we're going to plug in a plus h for x. So I'm definitely going to use parentheses here. X is a plus h squared plus 3a plus h minus 1. And then we can just start multiplying that out to simplify it as much as possible. So I'm going to give myself as much room here as possible. I'm going to do 2 times a plus h times a plus h. Okay, do FOIL here. I'm going to end up with 2a squared plus ah plus h squared. So that becomes 2a squared. So this here is 2ah, and then multiplied by this 2 is 4ah, and then multiplied by the 2 is 2h squared. All right, and then I need to multiply this 3 through, so I get 3a plus 3h, and then I have my minus 1 on the end. And then I can combine like terms, and I can get f of a plus h equals, well, actually nothing combined, so we can just rewrite this. And we're done. Okay, and then the last part of this example is find f at a plus h minus f at a, and then divide it by h. And then it has to clarify that h can't be 0 because we can't have a 0 in the denominator. So that just helps us, that just reminds us we can't have 0 in the denominator. So we're going to use our results from parts C and A. So we're going to f of a plus h minus f of a over h equals, we're just going to take this result up here and this result over here and subtract them from each other. Minus and remember, you're going to have to distribute that negative to all those spots eventually. So that actually simplifies to this 2a squared cancels with this negative 2a squared. And then this 3a minus 3a, those go away. And then this negative 1, and then this becomes plus 1 over here, so that goes away. So actually what we're left with is 4ah plus 2h squared plus 3h and that's it on the top, divided by h. Okay, but we can simplify this. So some of you guys got some points off on your test. I can take an h out of the top. And then if there's an h on the bottom, those can cancel. Okay, so f of a plus h minus f of a over h equals 4a plus 2h plus 3. And we already said that h cannot equal 0. All right, here are some notes for the domain of a function. So the domain of a function is the set of all input values x for the function. So that's not new to you. So some examples are that the domain can be stated explicitly in the problem. So in this problem here, f of x equals x squared. They tell you that x needs to be between 0 and 5 and including 0 and 5, or you can write it bracket 0, comma 5 bracket. And in this problem, the domain is given. Oftentimes the domain is not stated explicitly, and we have to assume the domain is all real numbers for which the expression is a real number. So any number that will make f of x work as a real number will be counted as the domain. So here's an example. F of x equals 1 over x minus 4. I've already told you that the denominator cannot be 0. So the only value here that won't work is when x equals 4. That will make the denominator 0. So the domain here, you can write it like this. X at any value, but x cannot be 4. Or you can write it in interval notation. That's going to be negative infinity, oh gosh, to 4, not including 4, and 4 to infinity, so that doesn't include 4. Well, I don't know if it's an and or an or sign, so I'm not going to write that. Okay, and then the next one is g of x is the square root of x. So the domain here, x inside of a square root, your rule here is that under a square root cannot be negative, because that will give you a an imaginary number. So that x, whatever's under the square root, has to be greater than or equal to 0, because it can include 0. So our domain is going to be x at any value except x needs to be at any value greater than 0 or equal to 0. And you can write that as including 0 up to infinity. Okay. So our example for today for that is find the domain of each function. So let's start with a. A is x 1 over x squared minus x. So remember the denominator cannot be 0. So I'm going to factor this. I have the bottom can be written as x minus 1. So be sure to be able to factor that. So that cannot equal 0. So that means x cannot equal 0 and x minus 1 cannot equal 0. So x cannot equal 1. So those are our two limits there. So the way we write this domain is x, where x cannot equal 0 and x cannot equal 1. And you can write it in interval notation as negative, oh my gosh, infinity up to 0, but not including 0. 0 to 1, but not including 0 or 1. 1 to infinity, not including 1. All right, b is g of x equals 9 minus x squared under the square root. So that whole thing under the square root has to be greater than 0, greater than or equal to 0. So I'm going to write that here. 9 minus x squared is greater than or equal to 0. It has to be a positive number. So 9 is greater than or equal to x squared. This is where it gets confusing. If you take the square root of both sides, you get that x is less than or equal to 3, or the same thing for negative 3, but you have to flip the sign the other way. Okay, so now we can solve. So now I'm going to write that in the form of x at any value except, remember, x needs to be, this one says x is greater than -3, and then this one says x is less than 3. So it's in between those two values, but including those two values. And then in interval notation, that looks like -3 including -3 up to 3 including 3. Okay, and then the next part C, h of t equals t over the square root of t plus 1. Okay, so there's two things here. We have a denominator and we have a square root. So let's just start with the square root. So the square root of t plus 1, that means t plus 1 has to be greater than or equal to 0. It can include 0 because the square root of 0 is 0. So then t has to be greater than or equal to -1. So that's our first limit. But now let's look. So we have this, but the square root is actually in the denominator. So actually t, if t equals -1, -1 plus 1, that equals the square root of 0, which equals 0. And actually, we can't have 0 in the denominator, so that's the second rule. So actually, t cannot actually equal -1. So t actually has to be just greater than -1. It can't include it. So this is our final restriction. So in order to write that, we need to say t at any value except t needs to be greater than -1, not including it. And you can write that as -1 to infinity, not including -1.